Hello, student. I hope that you are doing well. Welcome to Dr. Kimi's 2025 channel. I create some video in chemistry in very easy way for you. And I'm Hamid Reza Motivar. And today I want to talk about how to write in chemical formula in chemistry. It's a very long story, and I think most of the students have problem in this field. Actually, this is the first part of the writing chemical formula. You know that for the writing we have four categories, but today I want to just focus on the first part, binary ionic compound. You know, four parts consist of binary ionic compound, polyatomic ionic compound, binary covalent compound, and acid as a compound. But today, as I said before, I want to just focus on the binary ionic compound. Okay, let's get started. First of all, you know that the writing chemical formula is a like kind of the language. For example, in English, you have letters, word, and sentences. Letters goes together and can create words, and the words can create sentences. For example, letters, ABC, words, book, and sentences. For example, I wrote some books. In chemistry, letters is a kind of the element symbol, such as Na, sodium, potassium, K, or Mg, magnesium. So the elements, such as the letter. So when the elements go together, they can create chemical formula. For example, sodium and chlorine can create NaCl. NaCl is a kind of the word in English, and we call this one chemical formula. And today we want to talk about the chemical formula. I mean that so we need elements for the chemical formula. And after that, chemical formula can create chemical equation, such as the sentences in English, in your language. For example, NaCl plus AgNO3 gives AgCl plus NaNO3. But today we want to talk about chemical formula, such as words in English. Okay, as I said before, I want to talk about the binary ionic compound. Let me see. Where is my pen? Oh, the pen is here. And okay, we want to talk about the binary ionic compound. Binary ionic compound, it means a compound containing two elements, one metal and one non-metal. So we need metal and non-metal for the binary ionic compound. And in the next part, I want to talk about polyatomic ionic compound. It's a little complicated, but it's not very difficult. A compound containing at least one polyatomic ion. We will talk about the polyatomic ion. Do not worry about this. So in this part, for example, metal plus non-metal can create binary ionic compound. For example, metal can create a positive ion. For example, Na plus plus non-metal Cl minus can create NaCl, such as the sodium chloride. Let me talk about the ions at first, metals and non-metals. Let me talk about it. This is a periodic table, and I think that you are familiar with the periodic table. Okay. In the periodic table, this part, look at the pen. It consists of metals. More than 80%, 80% of the elements in the periodic table consist of metals. So metals are the most element in the periodic table. And here is a semi-metal or metalloid between the metal and non-metal. Sometimes they are metal, sometimes they are non-metal. Some property, physical property are metals and chemical property is metals, and sometimes the chemical property are non-metal or something like that. We will talk about them in the future. And this part, small part, is a non-metal. And you know that the metal loses electron. When they loses electron, they can create cation. Cation is a positive. And this part is a non-metal. Say they can gain electron. When they can gain electron, they can create anion. Anion is an element with a negative charge. Negative charge. Let me talk about the groups, because at this part I want to talk about common ions. Group 1, they can create, such as the lithium, sodium, potassium, rubidium, cesium, and francium, and sometimes the hydrogen. You know that the hydrogen is not belong to the group 1, but they put on the top of the group 1 because the electron configuration is like the group 1. That's why that the hydrogen is here. For example, lithium can create ion as a La positive because they are metals and they loses electron. For example, sodium is such as the lithium, or potassium such as the sodium. Group 2 has a beryllium, magnesium, calcium, strontium, barium, and rhodium. They can create ion with the 2 positive charge. For example, magnesium, 2 positive charge. Calcium, 2 positive charge. Group 3 or 13, they can create ion with the 3 positive charge. Boron, aluminum, gallium, indium, thallium. And the groups 4, we will talk about it in the future. They cannot create any ion. And group 3, they can create anion with the 3 negative charge. For example, N3 minus, P3 minus. Group 6 or 16, they can create ion with the 2 negative charge. O2 minus, sulfur, 2 minus, selenium, 2 minus. Group 7 or 17, halogens, fluorine, chlorine, bromine, iodine, acetine, they can create ion with the just only -1, F minus, Cl minus, Br minus, I minus. Astatine is radioactive. We not talk about the astatine in this part. And between the group 2 and group 3 or 13, we have a transition metals, this part. They can create some ion, and most of the important part is a zinc, Zn. Zn can create 2 positive charge. And copper, sometimes positive 1, sometimes positive 2. They are multivalent metals. We will talk about it. For example, iron 2, and iron 3. Chromium 2, chromium 3, and sometimes chromium 6 plus. And scandium, just scandium 3 plus. And mercury Hg, or silver is a positive 1. Mercury is positive 1 and positive 2. We will talk about it in the next part. So you get some information about the common ions in the periodic table, because we want to talk about the cation, and the metals can create cation. Cation is a positive, and the anion negative charge. Okay, let's go to the next page. Okay, so we want to talk about the binary ionic compound. Binary ionic compound. Let me change the color. As I said before, binary, it means 2 elements. Bi, it means 2. For example, when you are talking about the bicycle, it means 2 cycle. Binary ionic compound, it means ionic compound with the 2 elements. One is the metal, one is the non-metal. As I said before, metal plus non-metal can create a binary ionic compound. For example, sodium is the cation, and you know that the sodium is in the group 1, so it can create Na plus non-metal, such as the Cl minus, chlorine, and it's a anion, and they can create NaCl, sodium chloride. How we can recognize, identify, how we can recognize binary ionic compound? Do not worry about it. They get end with IDE, ide. Sodium chloride, ide. So when you heard about the ide, it's a binary ionic compound. For example, this is a sodium chloride. Look, ide. So when you heard about the ide, ide at the end, it's a binary ionic compound. So you can recognize it very fast, and it's easy. And I want to say something as a note. Please pay attention about the hide. hydroxide and cyanide. Look, they get end with a IDE, but they are not belong to this part. This is a kind of the exception. Hydroxide and cyanide is the polyatomic ion, and we will talk about it in the next part. So when you heard about something with the IDE or IDE, they are binary ionic compound, exception hydroxide and cyanide, they are not belong to them. Please pay attention to them. Okay, let's bring some example. For example, let me change the color. For example, I was asked write the calcium bromide. Okay, I go to the periodic table. Where is the calcium? And what is the symbol for the calcium? Calcium should be Ca. It's in the group 2, so the valency for this one or ion should be Ca2 positive. And the bromide, look, at the end you see the IDE or you heard bromide ide. So it should be binary ionic compound. And the bromide should be in the halogen group, Br. And as I said before, the anion for this part is a -1. So when you want to write a calcium bromide formula, you can create a neutral compound. Neutral compound. It means that the compound without any charge. If you wrote as a CaBr2, CaBr is not correct because Ca is a 2 positive and it's a -1. It's a 2 positive plus -1, it can create +1. It's not good way. So if you want to create a neutral compound, so you need 2 bromine. So it should be calcium 2 plus, 2 bromine, Br minus and Br minus. It should be 2 positive plus -1 plus -1. It can create a 0. So this one is okay. So calcium bromide, it should be CaBr2. That's why we need 2 bromine in this compound. This one is not correct. If you wrote as a CaBr, it's wrong. It's not in the nature. It's not true, but CaBr2 is true. And I want to say something. You can use the crossover method. It can easy way and do it faster. For example, when you want, let me do it here. Okay, let me change my color. Okay, so you can see this one. Yes. Okay. Oh, wait, sorry. For example, I want to say the crossover method. What is the crossover method? Crossover method is an easy way to create a neutral compound. For example, calcium and bromine. You know that the calcium is a 2 positive and the bromine is a -1. So the valency for the calcium is a 2 and the valency for the bromine is 1. So the calcium gives the valency to the bromine and the bromine gives the it gives the valency to the calcium. So it means 1 calcium and 2 bromine. It's a very easy way, and it can create like this. So this one is okay. So we use the crossover method. It's a very simple method to do something for the creating a neutral compound. Let me bring some more example. For example, another question it says, for example, magnesium sulfide. Look, at the end is sulfide, IDE. So it should be binary ionic compound, sulfide, magnesium sulfide. If you if you look at the periodic table, you can find that the magnesium in the group 2, so the valency should be 2 or 2 positive. And the sulfate in the group 6 or 7, 16. Below the oxygen sulfide. Sulfide should be S. As I said before, the common ion should be 2 minus. So the magnesium should be Mg2 plus and S2 minus as a sulfate. We have to create a neutral compound, and you know that the magnesium 2 plus and the sulfate is a minus 2, it can create a neutral compound, so it should be MgS. If you want to use the crossover method, the magnesium and the sulfate. Magnesium is the valency is 2, gives to the sulfate, and the sulfate gives 2 to the magnesium. And they can simplify by 1, and you do not need to write the number 1. So it should be MgS. This one is okay. Another example. Let me change this color. For example, I was asked to write potassium oxide, IDE at the end. When you heard about the IDE, so you can recognize this should be a binary ionic compound. Okay, if you look at the periodic table, potassium is belong to group 1, it should be create K plus, and the oxide is a group 6 or 16, 2 minus, such as the sulfide, oxide. You have to create a neutral compound. If you wrote K plus O2 minus, look, plus 1 plus minus 2 is not a neutral. So you need 2 potassium, because every potassium has positive 1 and 1 oxygen. So it should be plus 1 plus 1 plus minus 2. It can create a neutral compound. So it should be K2O. So you need 2 potassium. And if you want to use the crossover method, you have to we have to write the potassium oxide. Potassium should be K and the oxide should be O. The valency for the potassium should be 1 because it's in the group 1, and the valency for the oxygen should be 2, gives 2 to the potassium. It can create the K2O. Look, it is so simple. But this one is the meaning of the writing formula. Both ways are correct. And I prefer to do it like this crossover method because it is so fast for you. For example, I want to bring another example. For example, you want to write the barium nitride. Look, nitride. Nitride IDE at the end, so it should be binary ionic compound. Barium, if you go to the periodic table, you can find the barium in the group 2 should be 2 plus. And the nitrate, N 3 minus. Because in the group 5 or 15 periodic table, nitrogen at the top, phosphorus below the nitrogen should be P3 minus, phosphate. And the nitride, barium nitride. If you wrote, for example, barium and the nitride, is it neutral? Let me see. No, is number one minus one is not neutral. So you need 3 barium and 2 nitrate because they are positive 6 and they are minus 6. So you need barium 3 and 2 nitrate. But if you want to use the crossover methods, this one, barium should be Ba, nitride should be N. The valency for the barium is 2 because it's belong to the group 2, and the nitrate is 3, gives the valency to them. So you can create Ba 3 and 2, this one. Okay, student, I think that I bring some example for you. You have to get master to do more example about it. Look at the periodic table and you can create some binary ionic compound. I hope that you enjoy in this part. See you soon. Have a good time. Please subscribe in this channel to support me to create more videos for you, and hit the ring, and please like this kind of video. Have a great time. Bye bye.